Let's see that in the carbonyl compounds chapter, the 22 question. Last we are discussing the 22nd question. What is the 22nd question, dear students? Listen carefully. The first one is reductive ozonolysis. Reductive ozonolysis. Okay, reductive ozonolysis means the double bond is a disubstituted double bond. If you observe that the symmetrical disubstituted double bond is converted into aldehyde CHO group, and this is also converted into CHO group. So total how many carbons are present? 6 carbons are present, and 1 comma 6 diol will form. So the resultant product X is equal to, okay, the X is equals to 1, sorry, this is the first carbon, 1, 2, 3, 4, 5 and 6. Okay, 1 comma 6 hexane diol. Hexane diol will forms. Now this compound is treated with base, dilute NaOH. Base upon heating means is nothing but aldol condensation reaction. Aldol condensation reaction. Okay, students. So in the aldol condensation reaction, what is the product? Alpha beta unsaturated carbonyl compounds will get. See, for this reaction, this alpha carbon, any one of the C double bond O group, two CHO functional groups at one molecule only. In that one molecule, both are aldehydes only. That's why this is the alpha carbon. These two alpha hydrogen atoms and this oxygen will lose water molecule. Okay, then the final product is 5-membered cyclic ring will forms. Okay, the 5-membered cyclic ring and having CHO functional group. C double bond O H functional group. This is alpha carbon. This is alpha and beta. The double bond will form. Alpha beta unsaturated carbonyl compounds. Cyclic carbonyl compounds will get. So the answer is first option is correct. Okay, students. So very important. All condensation reaction applications and all are very important. Let's see the 23 question. In the 23 question, 2 methyl ketones are present. The total number of carbon atoms are 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons are present and C double bond O groups are present at 2 and 7th carbon. That first we are treated with base followed by heating, means aldol condensation reaction. So in the middle 1, 2, 3, 4 carbons are present. Okay, like this 4 carbons are present. Now C double bond was CH3. Now it is also C double bond was CH3 is present. Now the total number of carbon atoms, how many are present, dear students? Let's count. This is 1, 2, 3, 4, 5, 6, 7 and 8. So the first one we are treated with base upon heating. The second one, A and B, just I am combined and A and B I am writing. Okay, otherwise just you want to write A only, means in the presence of base forms stable enol. Stable enol. This is that this proton will be removed and form stable enol and O minus. Again it will be coming back and it will be attack. Here negative charge will be attack and attack will be at seventh position, undergoes aldol reaction. Aldol reaction. Okay, not aldol condensation reaction. Aldol condensation reaction means alpha beta unsaturated carbonyl compound will get. Now, what is the cyclic ring, dear students? 1, 2, 3, 4, 5-membered cyclic ring will get. So, this is the 5-membered cyclic ring is forming. At the 5-membered cyclic ring, that beta hydroxy C double bond O is present. This is alpha and beta. Beta hydroxy ketone is present. This is beta hydroxy ketone. Now this is on further heating, loss of water molecule and forms alpha beta unsaturated carbonyl compound. So this is A and the B is the B compound is like this. The double bond is in between C double bond O group and CH3 group, means more substituted double bond and alpha beta unsaturated carbonyl compound. This is alpha comma beta unsaturated ketone. Means this is the second step is aldol condensation reaction. Aldol condensation reaction. So from A to B directly, from the starting material to B, the B product is aldol condensation product. The next step what we are doing, dear students, we are treated with hydrazine NH2 bond NH2 in the presence of base, means is nothing but Wolff-Kishner reduction. Wolff-Kishner reduction we are doing, then it reduces only the C double bond O group. It reduces C double bond O group into CH2 group. Then the final product is it cannot reduces the double bond. Okay, it cannot reduces the double bond. So that is the answer. Let's see that. Like option where it is present, dear students. Third option is correct. Third option is correct. Let's see, this is the option. So first one aldol reaction, the second product is condensation product, and third product is a Wolff-Kishner product, and C double bond O group will be converted into CH2 group. Okay, so it's very important, these conversions. Let's see the next level 3 questions. Level 3 questions very easy. This is also, dear students, just a little bit we have to observe carefully, then we'll get answer very easily. Okay, so let's see the first one. X plus O3 means reacts with ozone followed by reductive hydrolysis, means reductive ozonolysis. The product is CH2 CH double bond O and CH double bond O. Okay, this is the resultant product. Now what is X, we need to identify. How this product is formed, dear students? Let's listen. This product is formed means whenever double bond is present, like the double bond is present, treated with ozone followed by reductive hydrolysis, then we'll get CHO bond, CHO is formed. Means it is cyclobutene. Cyclobutene is the X. And how can we identify where the position of double bond is, students? How can we identify? See this C double bond O group and C double bond O group, remove the oxygen, minus O2, just you connect that both, then CH double bond CH, then we will get CH, and here CH is present and both you connect as a double bond, then this is cyclobutane. So this is the X. Okay, so the answer is a cyclobutene or cyclobutanene is the correct. Second option is correct. Okay, let's see the second question. The second question is application of Clemmensen reductions, Clemmensen and Wolff-Kishner reduction. So both products I will write, dear students. What will happen? This C double bond O, and at meta position CH2 bond N trimethyl is present. CH3 and CH3. If it is the product what we want to product, dear students, the resultant product is just we have to reduce C double bond O group only. So the C double bond O group is reduced into CH2 group and without affecting this amine product. Means it is possible in the presence of zinc amalgam HCl. Zinc amalgam HCl means Clemmensen reduction. Clemmensen reduction. In the Clemmensen reduction, it is taking place in acidic medium. It affects the acid labile groups, but NH3 quaternary ammonium salt NH3 plus is acidic group, so does not affect this group, but in the same way is treated with base hydrazine followed by base, means OH minus ion, then is nothing but Wolff-Kishner reduction quaternary ammonium salts quaternary ammonium salt converted into alkenes by the Hoffman elimination reaction. And it is also reduced as C double bond O group is into CH2 group. So the resultant product is this hydrogen will be replaced this. The resultant products are plus trimethyl quaternary ammonium salt will forms, and this CH2 bond CH2, this group is converted into alkene, and this C double bond O CH3 group is converted into alkane group, because the quaternary ammonium salts in presence of basic medium undergoes elimination reaction is known as a Hoffman elimination reaction and forms less substituted alkenes are the major product. So without affecting this quaternary ammonium salt, the C double bond O group is converted into alkanes, means that is taking place in acidic medium only, that is Clemmensen reduction, Clemmensen reducing agent. Lithium aluminum hydride and sodium borohydrates are present, they can reduce as C double bond O group into OH group, means the carbonyl group is converted into alcohols only, cannot be converted into alkanes. So the answer is a Clemmensen reducing agent. Second option is correct. Okay, let's go for next question. Without affecting this ether functional group, this ether functional group will be affected in acidic medium as well as in basic medium also. That ethers can be cleavaged in acidic medium, converted into alcohols, as well as in basic medium hydrolysis also converted into alcohols. But they cannot be without disturbance. That ether functional group means we have to use that. First we see double bond O group, we have to protect it with ethane dithiol, followed by reduction in the presence of nickel catalyst. Then is converted into alkane. Okay, let's see the third question. I will write all different conditions. The first one, CH3, C double bond O, CH2, bond CH2, bond CH, bond CH2, O, and this is in acidic medium. You want to do the reduction takes place in acidic medium. Zinc amalgam in HCl, then acid labile group will be effect, and the H plus ions that it will be opening forms more stable carbocation. The opening of epoxide at sterically more crowded side. In acidic medium, the opening of epoxide will be takes place and sterically more crowded side, and this group is converted into CH2 group. Okay, now the resultant product is CH3, CH2, CH2, bond CH2, bond CH2, followed by hydrolysis, then CHOH, and bond CH2OH will form diol. Hydrolysis. In the same way, the basic medium you are doing hydrolysis means hydrazine in the presence of base. Basic medium hydrolysis we are doing also. Then this it will be break is converted into CH3 bond CH2 1 2 3 bond CHOH bond CH2OH. In basic medium, the epoxides will be cleavage in sterically less crowded side. Then secondary alcohol and one more OH group nucleophile will be attacked. But in the same way, this product without cleavage of this ether linkage, first we have to treat it with ethane dithiol and loss of water molecule. It will forms like this, that C double bond O group will be protected by ethane dithiol and CH2 bond CH2 bond CH bond CH2O, and Rani nickel hydrogenation takes place in the presence of nickel catalyst. Finally, powdered and activated nickel is called Rani nickel. Then it will be cleavage this group into CH3 group. Again, this CH3 bond CH2 bond CH2 bond CH2 bond CH and CH2O. This ether, cyclic ether cannot be disturbed. Cyclic ether cannot be disturbed, and the C double bond O group is converted into alkane. So the correct suitable reagents are ethane dithiol followed by reduction takes place in the presence of Rani nickel. Whenever epoxides are present, then the reduction of C double bond O group, Wolff-Kishner reducing agent and Clemmensen reducing agents are not suitable, because epoxides are epoxide group will be cleavage, cyclic epoxides group will be cleavage either in acidic medium as well as in basic medium also. So epoxides are nothing but cyclic ethers. Okay, students. So the answer is third option is correct. Let's see that fourth question. See, NO2 group is acid labile group. Zinc amalgam HCl. The HCl completely will reduce NO2 group into is nothing but Clemmensen reduction reducing agent. Reduction, and in acidic medium this NO2 group is reduced into to NH2 group. And in Clemmensen reduction, the C double bond O group is converted into CH2 group. So the resultant final product is this NO2 is converted into NH2 and C double bond O CH3 group is converted into CH2 CH3. Okay. 3-ethyl aniline is the product. So the answer is third option. Okay, students, very, very important this kind of questions. See here, two different functional groups are affected by one reagent, especially Wolff-Kishner reducing agent applications and Clemmensen reducing agent applications all are very, very important. Okay, let's go for next question. Let's see fifth question, dear students. What is the fifth question? Hydrazine and base. In basic medium, alkyl halides undergoes dehydrohalogenation forms alkenes because the Wolff-Kishner reduction is taking place in the presence of basic medium OH minus ions. Okay, now the base removes this beta hydrogen and alpha halogen, loss of HBr, and the C double bond O group is converted into CH2. Now the resultant product is CH2 CH3 and at para portion ethyl bromide is converted into ethene, CH double bond CH2. Okay, so the resultant answer is second option. Is nothing but in the bond line structure. Do you want right means the benzene ring having vinyl group substance CH double bond CH2 means styrene and also having ethyl substance is present. So that is the answer. Okay, let's see the fifth question over. Now the sixth question, see. What is the sixth question, dear students? The sixth question, HNO3 is a strong oxidizing agent. Then the cyclic ketones are converted into dicarboxylic acids. Cyclohexanone is a strong oxidizing agent. Then this C double bond, according to Pfaff rule, the C double bond O group attached single bond completely will be break down and is converted into two carboxylic acid groups. Means adipic acid will get. Adipic acid means COH and COH group. Okay, is nothing but 1, 2, 3, 4. 4 CH2 groups are present. CH2 4 times COH and COH is adipic acid. Adipic acid. Okay, this adipic acid is treated with calcium hydroxide, loss of water molecules, calcium salts of adipic acid will get. And Ca+2. Okay, this is on heating. This is upon heating, loss of calcium carbonate. CaCO3 converted into ketone, cyclic ketone will get. Already preparation methods of ketone from calcium salts of carboxylic acid, there we discussed. This one carbon less will forms. means one carbon less. Here how many carbons are present, dear students? Here the number of carbons, 6 carbons are present, and the resultant product has only 5 carbons, means CH2 4 times C double bond O. Here 3 C double bond O bond CH2 group will form. Total 5 carbons containing cyclic ketone will get. Cyclopentanone is the product. So the answer is third option. Means what is this conversion, dear students? Cyclohexanone. 6 carbons cyclic ketone is converted into 5 carbon cyclic ketone. How it is possible? First treated with strong oxidizing agent, upon treated with calcium, calcium hydroxide on heating, then we are getting 6 carbons containing cyclic ketone is converted into 5 carbons containing cyclic ketone. Conversions man. So one carbon will be decreased. Okay, that carbon, how it will be decreased, dear students? It is eliminated in the form of calcium carbonate, CaCO3. Okay, let's go for 7th question. Seventh question is very, very important, dear students. Either lithium aluminum hydride or sodium borohydride. See, here the reactivity of reactivity order LAH, lithium aluminum hydride, is more than sodium borohydride. Okay, so both can reduce as C double bond O group into alcohols, aliphatic and aliphatic alpha beta unsaturated double bond cannot affected by both, but aromatic unsaturated alpha beta unsaturated carbonyl compounds present LAH reduces into saturated alcohol, but NaOH, NaB4, sodium borohydride, reduces only C double bond O group into alcohol. Okay, so that is the difference, ma. So generally it is alpha beta unsaturated aliphatic carbonyl compound. Okay, so use LAH, lithium aluminum hydride, or sodium borohydride. Sodium borohydride, it cannot reduces this double bond. The double bond cannot be reduced. OH will present, then its name is butane, 2-2-in-1-ol, So the answer is a third option. Let's see in the same place. Aromatic alpha beta unsaturated carbonyl compounds are present. LAH, lithium aluminum hydride, completely reduces this double bond also. then is converted into saturated alcohol, CH2 bond CH2 bond CH2OH. But sodium borohydride, CH double bond CH, CH2OH, only it can reduce as carbonyl group. That's why lithium aluminum hydride is more reactive when compared to sodium borohydride. But either lithium aluminum hydride or sodium borohydride cannot reduces the double bonds in aliphatic conjugated carbonyl compounds. But in aromatic conjugated carbonyl compounds, the lithium aluminum hydride can reduces double bond also. The double bond converted into single bond. Okay, is very very important, ma. Let's see that ninth question, eighth question. What is the given eighth question, dear students? See, sodium borohydride. Just now only we discussed sodium borohydride cannot reduce as this C double bond O group. So just the product is pH CH2OH. So the answer is first option is correct. First option is correct. But LAH is present, then it can reduce as the double bond. So if LAH is present, lithium aluminum hydride is present, the product is this. So the answer is third option. Second option is correct when lithium aluminum hydride is present. Sodium borohydride is present, first option. Okay. Next, ninth question. Let's see, dear students. A plus B is converted into, in the presence of diluted base, converted into alpha beta unsaturated ketones. Alpha beta unsaturated ketone is the product. C, diluted base upon heating means aldol condensation reaction is nothing but aldol condensation product. So just what is the product directly you write, then according to that A and B we can identify very easily. In the presence of base upon heating, the product is pH CH double bond CH C double bond O CH3. Okay, so this A and B we want, A plus B. Now just this double bond you break, then imagine that this is oxygen, cross aldol condensation. Cross aldol condensation. So one product is PHCHO, benzaldehyde. Another product is CH3, means this two alpha hydrogen atoms and oxygen. Carbonyl compound oxygen we lost in the water. That's why that CH and two hydrogens it becomes CH3, C double bond O, CH3. So is nothing but acetone. This is a benzaldehyde. Okay, so A and B are benzaldehyde and acetone are the correct. So according to that, the correct option is, what is the option, dear students? The option is acetone and benzaldehyde. Third option is correct. Third option is correct. Acetone, let it be A, and B is benzaldehyde. So it is A. This is A they are considered, and this is B. Okay. Next. Let's see that 10th question. It's very easy. 10th question, just conversions, very very important. What are A and B reagents they are asked? Let's see. A, if alpha beta, this double bond is present and C double bond O group is also present. means LAH is not suitable. For this case, this A not suitable for LAH because it is not aromatic alpha beta. LAH is not suitable and sodium borohydride is also not suitable. But A must should be A is equal to metals hydrogenation in the presence of nickel or platinum or palladium catalyst. Then they can reduce its double bond as well as ketones also. Okay, so the A is must should be hydrogenation in the presence of nickel, platinum or palladium. And B, sorry, reverse I said, dear students. Again, let's listen carefully. So the A is means double bond as it is came. Double bond is not reduced. So the A must should be either lithium aluminum hydride or sodium borohydride. A must should be either lithium aluminum hydride or sodium borohydride followed by hydrolysis. And B must should be hydrogenation in the presence of nickel or platinum or palladium. Okay, then it can reduce its double bond as well as carbonyl group. Carbonyl groups convert into alcohol and double bond convert into single bond. So the suitable reagent is either B. Third option is not clear, not correct because LAH. It is not possible. First and second also not possible. Okay, the correct answer is fourth option. First LAH, A is LAH, B is H2 in the presence of platinum. Let's see the 11th question. Trimethyl acetaldehyde treated with base means no alpha hydrogens. No alpha hydrogen atoms means absent. Alpha hydrogen atoms are absent in the presence of base means Cannizzaro reaction. Okay, now the Cannizzaro reaction is nothing but what are the products? One is acid, another one is alcohol. Means the products are itself undergoes self oxidation and reduction will take place. The product is CH3 thrice C double bond O minus plus CH3 thrice C bond CH2OH alcohol. One is acid, the second one is alcohol. Carboxylate ion and alcohol. So the answer is first option. Because OH minus only followed by hydrolysis, then we will get carboxylic acid and alcohol. Okay, so the first option is correct. Okay, students. Let's see that 12th question. This is very important. The 12th question is Clemmensen reduction reaction. The Clemmensen reduction reaction, OH group is acid labile group. Whenever treated with zinc amalgam HCl, this H plus and Cl minus, this water molecule, OH has lone pair electrons are present, then it is converted into CH2. So the product is H2O plus. To loss of water molecule, then Cl minus will be attacked. Then the final product is chlorine will form. So the answer is first option is correct. So C double bond O group is converted into CH2 and the OH group is converted into Cl, because the OH group in acidic medium, alcohols are converted into, the alcohols reacts with HCl, then is converted into alkyl chlorides, loss of water. That's why third option is correct. Okay. Okay, students, let's listen. Which statement is about aldol condensation is correct? Which statement is aldol condensation is product? Aldol condensation means what, my dear students? The initially the aldol condensation is takes place in the presence of base medium. Base upon heating means they forms carbanion intermediate. Carbanion intermediate will forms. Okay, so the answer is the initiation step is probably by the formation of carbanion intermediate. Then it will be attacked to the another carbonyl group, converted into beta hydroxyaldehydes upon heating. Alpha beta unsaturated aldehydes are the product. Okay, let's see the 14th question. A compound gives the positive test with iodine and base means and is extracted from benzene. Extracted from benzene by saturated sodium bisulfate means it is nothing but methyl ketone. The compound A is a methyl ketone. Methyl ketone. It gives positive sodium iodine in the presence of base means it gives iodoform test. Iodoform test. What is A? They are asked. So among that, the A is second option because it is a methyl ketone. Methyl ketone gives a positive haloform test or iodoform test. Okay, so second option is correct. Let's see that 15th question, dear students. 15th question is very, very important. NBS is used for the allylic brominating agent. NBS is nothing but allylic bromination takes place. Okay, what are the allylic positions? And here both symmetrical, secondary carbon only. So the first allyl bromide will forms. Okay, next we are treated with magnesium ether. Means Grignard reagent it will forms. And the product is MgBr, Grignard reagent. This treated with hydrogen cyanide followed by hydrolysis. This Grignard reagent acts as a nucleophile, then produce the product is C double bond H and double bond N MgBr. This followed by hydrolysis. Hydrolysis, then we will get aldehyde group, CHO group. So the answer is a fourth option. Okay, students. So this conversion is very, very important. First, allylic bromination takes place. Later is converted into Grignard reagent. The Grignard reagent treated with hydrogen cyanide HCN. Then followed by hydrolysis, we are getting aldehyde. Instead of hydrogen cyanide, it is treated with methyl cyanide CH3C triple bond N. Then what is the product? Methyl cyanide followed by hydrolysis. Then the product is ketone. C double bond O, CH3. Ketone is the product. Okay. So hydrogen cyanide, alkyl magnesium halides treated with hydrogen cyanide followed by hydrolysis produce aldehydes. Except hydrogen cyanide, any cyanides, alkyl cyanide treated with Grignard reagent followed by hydrolysis produce ketones. Okay, very important. Okay, the remaining next class will discuss. Okay, students.